The enigmatic dwarf planet dwelling on the outer reaches of our Sun machine is stirring up exhilaration in the astronomical community. Latest reports trace at a possible come across with Neptune, raising issues among scientists and space enthusiasts alike. FEMEND professionals, along with Neil deGrasse Tyson and Michio Kaku, have sounded alarms about the potential effects of this celestial clash. But how did Pluto come to be on a collision route with its distant neighbor, and what might this cosmic collision suggest for us here on the Earth? Permits discover this unfolding occasion. As soon as considered a complete-fledged planet, Pluto changed into later reclassified as a dwarf planet because of its precise orbit. Despite this alteration, it keeps to captivate and have interaction astronomers. Recent predictions from prominent scientists spotlight a traumatic proximity among Pluto's route and that of Neptune. These professionals warning towards a capacity collision between the two planets, posing a large danger to Earth. Pluto's adventure across the Sun is marked through its unprecedented traits inside our solar machine. Its orbit spans an intensive 248 years, and considering its discovery in 1930, Pluto has yet to complete a complete revolution. Including to its intrigue is the surprisingly elliptical shape of its orbit, a departure from the nearly circular orbits of the main planets. Moreover, Pluto's orbit is inclined at 17 degrees to the ecliptic aircraft, making its route steeper in comparison to different planets. One notable element of Pluto's orbit is its intersection with Neptune's direction. For about 20 years in every orbit, Pluto ventures closer to the Sun than Neptune, defying expectancies based on their respective positions inside the Sun device. So why hasn't a collision happened among Pluto and Neptune? The rationale lies within the gravitational impacts exerted by means of different planets. The examination of Pluto's orbit commenced rapidly after its discovery, providing a puzzling trajectory for astronomers. Not like most people of planets whose orbits align incredibly near the ecliptic plane, Pluto's one-of-a-kind functions encompass a steep inclination and an elliptical form. The mystery deepened with the realization that Pluto's orbit crosses that of Neptune. The stability of Pluto's orbit amid those intricacies serves as evidence of the complexities inherent in space mechanics. The three-body hassle in area includes information the motion and gravitational interactions amongst three celestial bodies, consisting of Pluto, Neptune, and the Sun. This problem elucidates the complicated interaction of their paths and gravitational pulls. Terms like azimuthal libration, range libration, and the VZK oscillation make contributions to unraveling this celestial puzzle. Astrophysicists assert that the azimuthal libration accountable for maintaining planets in their orbits performs an important role in the context of Pluto and Neptune. This time period means that while Pluto intersects Neptune's orbit, it's far positioned at the least 90 degrees away from Neptune, crucially preventing ability collisions. Latitude libration ensures that once Pluto techniques Neptune or other massive planets, it's far situated notably above their orbital aircraft, presenting an extra layer of safety against collisions. The VZK oscillation explains why Pluto's orbit around the solar seems uncommon but remains easy through the years, notwithstanding obvious randomness in space. Numerical simulations within the overdue 1980s discovered that despite solid residences, Pluto's orbit is technically chaotic, with minor preliminary deviations leading to considerable differences over hundreds of thousands of years. However, Pluto's unique orbit continues balance over incredibly long timescales, preserving chaos in take a look at. Latest PC exams have bettered our expertise of ways big planets like Neptune, Jupiter, and Saturn affect Pluto's course across the solar. Neptune's precise courting with Pluto, completing 3 orbits for every 2 of Pluto, appreciably contributes to the steadiness of Pluto's orbit. Additionally, Jupiter's significant gravity exerts an enormous effect on, at the same time as Saturn's effect, although smaller, also performs a role. Via comprehensive checks, scientists have proven that the blended results of Neptune, Jupiter, and Saturn make certain the secure and stable movement of Pluto in space for billions of years. Those phenomena are vital for retaining the order and predictability of celestial actions inside the universe. Without these mechanisms, the solar machine might be vulnerable to more chaos and unpredictability, probably main to collisions or ejections from strong paths and causing ripple effects on other celestial bodies. Knowledge Pluto's orbit is particularly vital amid discussions approximately a capacity collision with Neptune within the future. This understanding presents a clearer know-how of the dynamic nature of the Sun gadget. Pluto's case highlights how reputedly unstable orbits can reach equilibrium through the tricky interplay of gravitational forces and orbital mechanics. Non-stop observation and study of these phenomena are critical for gaining a higher hold close of our role within the universe. Exploring the depths of space often exhibits the unpredictable nature of celestial bodies, and Pluto's orbit serves as a high instance of this unpredictability. The concept of orbital chaos vividly illustrates the touchy dependence of a celestial body's direction on its initial situations. As verified in Pluto's case, even moderate versions within the dwarf planet's roll or velocity can notably adjust its long-term orbit. Laptop simulations were instrumental in helping scientists apprehend how Pluto movements in area. By means of making small modifications in these simulations, astronomers can take a look at how minor tweaks could have a widespread effect on Pluto's trajectory. Within the late 80s, these simulations discovered an exciting issue of Pluto's route. Notwithstanding capabilities like azimuthal and latitude libration contributing to its balance, Pluto's orbit can nonetheless showcase unpredictability. Even a tiny initial distinction in Pluto's function or velocity can lead to large changes in its route over a few years. Regardless of this inherent chaos, Pluto's orbit remains strong for a really long term, extending over billions of years. This shows that underneath its reputedly erratic look, Pluto's journey around the solar follows a structured order. Predicting cosmic activities, specifically with planets like Pluto that have unpredictable orbits, is pretty difficult. The inherent unpredictability of these structures makes long-term forecasts unsure. Numerical simulations assist us apprehend and assume the destiny paths of celestial bodies. However, they also reveal the boundaries of our predictive skills. Those models closely rely on accurate initial conditions and simulate complex interactions. Even a small blunders can lead to noticeably one-of-a-kind consequences, making unique predictions difficult. The chaotic nature of celestial orbits, inclusive of Pluto's, reminds us of the ever-changing universe. While we've made progress in expertise area, Pluto's case highlights our ongoing limited knowledge. Expertise, the gravitational impacts of massive planets on Pluto's orbit, affords precious insights into the broader dynamics of the Sun system. It demonstrates how each planet's presence and function can affect the stableness and trajectory of other bodies within the gadget. Despite these complex forces, primary astrophysicists are expressing concerns about a capability collision between Pluto and Neptune. This raises questions about why such a collision, which seems not likely given those elaborate dynamics, is now a topic of problem. Neil deGrasse Tyson, a 9AAF3F374C58891 1EF10256FA5 astrophysicist, offers a special standpoint on the mysteries of our solar system, mainly concerning Pluto. Tyson, famous for reclassifying Pluto as a dwarf planet rather than a full-fledged planet, shares insightful thoughts on how our know-how of celestial mechanics is always evolving. Tyson sees Pluto's reclassification no longer as a demotion, but as an essential adjustment to our increasing information about the diverse items circling the solar. His approach to celestial mechanics includes chronic gaining knowledge of and model. He views the complexities of orbits like Pluto's as a reminder of how a great deal more there is to find out in area. Tyson believes that the appeal of these unfamous is what makes astronomy so charming. Moreover, Tyson is aware of how area-associated occasions and discoveries form public interest in astronomy. He thinks occurrences like Pluto's reclassification and its unusual orbit are opportunities to capture the general public's imagination and curiosity, approximately the universe. By discussing the dynamic and now and again counterintuitive elements of space mechanics, Tyson objectives to foster a deeper expertise and appreciation of the cosmos. He opens a window for most people to surprise on the wonders and mysteries of the universe. Working alongside different scientists, Tyson actively cautions the public approximately the potential threat of Pluto's unpredictable direction. After Hughes take a look at Pluto, he has raised concerns that the three-body hassle might pose an actual risk, suggesting that a collision with Neptune is long past due. Additionally, Tyson emphasizes how such a collision may want to disrupt the balance of the universe and cause catastrophic consequences extending to Earth. A collision among Pluto and Neptune might be an uncommon and catastrophic occasion in our solar machine. This collision might launch a massive quantity of strength, in all likelihood breaking aside Pluto due to its smaller size and icy composition. Particles from the collision ought to scatter across the solar system, posing capability risks for different planets and their moons. For Neptune, such an effect could probably alter its environment and orbit, relying at the particular information of the collision. Michio Kaku, a 9AF3F374C588C9DCDD1EB10256FA5 theoretical physicist diagnosed for his paintings in string theory and technological know-how popularization, gives a completely unique angle in this situation. His perspectives at the destiny of space exploration and the relationship among celestial mechanics and theoretical physics provide deep insights into phenomena like Pluto's orbit. Kaku sees the have a look at of Pluto and its orbit as a glimpse into the future of area exploration. Information the complex gravitational interactions and orbital dynamics of celestial bodies like Pluto, in step with Kaku, can offer crucial insights for destiny area missions. This know-how can help in navigating the solar system greater efficaciously, predicting capability risks, and making planned missions to the outer reaches of our sun system and beyond. Kaku emphasizes that the training found out from studying Pluto's orbit may be implemented to explore different celestial bodies, presenting a blueprint for drawing near and understanding remote worlds. In discussing the physics of planets, Kaku often highlights the deep connection among celestial mechanics and theoretical physics. He believes that the movements and interactions of planets, consisting of the gravitational dance between Pluto and Neptune, are not isolated events but are connected to essential principles of physics. Kaku's work in theoretical physics, specifically in string concept, goals to recognize those concepts at the most essential stage. He suggests that reading the complexities of celestial mechanics, just like the orbit of Pluto, can yield insights into the underlying legal guidelines of the universe. Just like Tyson, Kaku has additionally addressed the capacity collision, bearing on it to his theories approximately the universe. If Pluto and Neptune have been to collide, it might be a huge occasion in astrophysics, providing a completely unique observational possibility that might doubtlessly contribute to our knowledge of string theory. String principle, a theoretical framework replacing factor-like particles with one-dimensional strings, seeks to explain the essential forces and matter within the universe. The collision of such significance inside the Sun gadget ought to create excessive situations of energy and gravity, imparting insights into the conduct of essential particles and forces below excessive situations, a key consciousness in string theory. Moreover, the gravitational waves produced by way of the collision ought to offer valuable data for checking out predictions of string theory associated with gravity and spacetime. Whilst the direct effect on this planet might be negligible because of our distance from the outer solar device, the clinical implications of such an event could be profound, doubtlessly contributing to our know-how of the fundamental nature of the universe as described with the aid of string idea and different areas of theoretical physics. Pluto's orbit serves as a first-rate instance of celestial mechanics, showcasing each balance and chaos within our sun machine. The particular traits of its orbit, motivated by the gravitational forces of neighboring planets, mainly Neptune, highlight the complex and dynamic nature of space. The universe holds many mysteries, and the three-frame trouble is just considered one of them. There are other capacity failures that scientists anticipate. While the chances of planets colliding in space are extremely low, it's now not entirely not possible. The way planets' orbits are stimulated through various factors, which includes gravitational interactions, is explained with the aid of the three-body trouble. In a few area systems like TRAPPIST-1 with 7 Earth-sized planets, the gravitational forces create a rhythmic sample known as orbital resonances. Through the years, these styles could make planetary paths less solid, probably main to collisions. Notwithstanding the crowded nature of systems like TRAPPIST-1, collisions are not presently taking place. Scientists intently display these systems to recognize how planets influence each other's paths, in particular while they are close to. This information allows us to recognize the motion of planets in space. Rogue planets, floating through area without orbiting a celebrity, introduce a further unpredictable element. Those planets, previously part of a celebrity machine, are expelled due to gravitational disturbances or other celestial activities. As rogue planets traverse vast distances, they'll reach regions some distance from their starting place. In the course of their solitary adventure, there's a possibility of them intersecting with other celebrity structures. If this kind of nomadic planets enters another sun machine, there is a moderate danger of a collision with a planet in that machine. However, given the sizable and predominantly empty nature of space, the likelihood of a rogue planet directly impacting every other planet is very low. The vastness of interstellar distances and the shortage of planets in open area serve as deterrents against frequent collisions. Additionally, rogue planets are especially unusual compared to the range of stars and planets in strong orbits, making such encounters even extra improbable.